This video presents an overview of tables and graphs for quantitative data. The most commonly used graphic types are histograms and box plots. As with categorical data, we generally start with a frequency table. For quantitative variables, raw scores are usually sorted into categories. In this frequency table, the first column indicates the category into which values will be placed, and the next columns indicate frequency and percentage. Percentages are often rounded to the nearest integer for readability. There are 4 rules for creating these categories. First, they must all be the same width. Here, each category contains values for one integer. They include both lower and upper limits, and they must be mutually exclusive of one another. This means that they do not overlap, so that scores can be placed into only one category. Finally, they must be collectively exhaustive. That is, they must account for all the data. Histograms look much like bar graphs, but because the x-axis represents a quantitative variable, the categories abut one another. Each bar represents a category from the frequency table. The difference between a histogram and bar chart is the measurement scale. The bars in a histogram represent quantitative data. Those in a bar chart represent a qualitative variable. We look for 4 things when examining a histogram: shape, center, and dispersion, and whether there are outliers. For shape, we focus on symmetry, and this distribution looks fairly symmetric. We could estimate the center, that is, the mean or median, to be somewhere near here, and the range is about 11 points. There are no exceptions or deviations from the general pattern, so no outliers. One important point: graphs are great for showing shape and pattern deviations. We can also get a general idea of central tendency and dispersion. But we always rely on numeric descriptors for making definitive statements about these characteristics. For this distribution, any of the 3 measures of central tendency provide a good description of the middle, in which case we generally report the mean. A good way to visualize symmetry is to superimpose a normal distribution on the histogram. This shows the number of days of frost for the month of April over a 65-year time period. There is a small number of values, so there was no need to create categories. The distribution appears to be positively skewed. The median is somewhere around here, but the mode is 0, so it's not a good measure of central tendency. The range is 10 days, and there are no deviations from this overall skewed shape. This distribution appears to be negatively skewed. The middle might be around here, and the range is about 70 years. This score may be an outlier. We might be inclined to think that this distribution is negatively skewed because of the extreme score to the left. But there is also a value separated from the rest of the distribution at the upper end, so this is a great example of why we rely on numeric descriptors. The middle seems to be about here, and the range is somewhere between 15 and 16%. Because of these 2 scores, we would examine the data more closely to determine whether they are true outliers. In this distribution, we can see a clear negative skew, with 3 suspected outliers. This is an outdated graphic because nobody buys CDs anymore, but many years ago, most teenagers spent as much of their parents' money on CDs as they could wheedle out of them. And this outlier shows that some were quite successful. This is a positively skewed distribution, which the normal distribution highlights. It is also a good example of when the mean is not a good measure of central tendency. The mode is also not a good measure because it's at the low end of the distribution. That leaves the median as the best measure of central tendency for these data. A box and whisker plot, or box plot, shows a distribution in terms of quartiles. This box plot shows age, shown on the y-axis. Let's dissect it. First, there is a line in the middle of the two boxes that indicates the median, or second quartile. The outer edges of the boxes represent the first and third quartiles. The lines, or whiskers, show the distance from the first quartile to the smallest value that is not a suspected outlier, and from the third quartile to the largest value that is not a suspected outlier. Each of the four segments contain the same number of observations, so we can get a sense of the shape of the distribution by comparing them. These all seem very similar in size, so we would say that the distribution is fairly symmetric. This is what the data look like as a histogram. It's not exactly normal, but appears to be fairly symmetric. Here, the two boxes look similar in size, indicating that the middle half of the distribution is fairly symmetric. But the upper whisker is longer than the lower one, suggesting a more extreme value or two in the upper range. We also might suspect a slight positive skew, but the skewness value indicates that it's well within range of a symmetric distribution. As a histogram, we see a slight gap between the highest value and the rest of the distribution, which accounts for the longer whisker in the box plot. The O's at the top of this box plot indicate potential outliers. The numbers next to the O's are subject numbers, which help us to find them in the data file. This appears to be positively skewed, but the skewness value tells us that it is only slightly skewed. These observations were tagged because they met the rule of thumb for suspected outliers, more than 1.5 times the interquartile range beyond the third quartile. And we can see these outliers on the histogram. This box plot shows one outlier and one observation that has been tagged as a possible extreme score, a value more than 3 times the interquartile range beyond the third quartile. Interestingly, this distribution is fairly symmetric. So despite the occurrence of both an outlier and an extreme score, the distribution follows a fairly normal shape. Histograms and box plots are commonly used to graphically describe quantitative variables. Histograms show the distribution of values or ranges of values, and box plots show the median and interquartile range as well as potential outliers. Both are useful for providing a general sense of shape, center, and dispersion, as well as potential deviations from the overall pattern. But we always rely on numerical descriptors for definitive interpretation of our data. In the next video, we'll describe the relationship between two variables.